Hi students, in the last video we explained how to write the electronic configuration and what are the rules to be followed while writing the electronic configuration. Electronic configuration is nothing but the distribution of electrons in main levels, sublevels and orbitals. Okay, we already discussed some of the electronic configurations, how to write by following the Above principle, Hund's rule and Pauli's exclusion principle. These three are the rules which we are following while writing the electronic configurations. Once again I may discuss the electronic configuration of various kinds of elements. Now see the example in the case of sodium. Its general representation is Na1123. That means it contains 11 electrons, 11 protons, 23 minus 11, that is nothing but 12 neutrons. These 11 protons and 11 neutrons are there inside the nucleus. Then what about these 11 electrons? As per the rule, first of all, they will occupy the lowest energy of orbital 1s. So 2 electrons are accommodated. Next orbital is 2s. 2 electrons are accommodated. After 2s, next energy orbital is 2p. P maximum 6 electrons. Now totally 10 electrons are completed. Remaining 1 electron is left. As per the above principle, after 2p, next energy highest orbital is 3s. So the last electron, that is 3s electron, the last electron enter into the 3s. So that is the electronic configuration becomes 1s2, 2s2, 2p6, 3s1. Next element is magnesium. Magnesium general representation 12Mg24. That means it contains 12 electrons, 12 protons and 12 neutrons. 24 minus 12, that is 12 neutrons. Now if you consider these 12 protons and 12 neutrons are there inside the nucleus, what about these 12 electrons? First of all, as per the above rule, it is enter into the 1s orbital. After 1s, next orbital is 2s, next orbital is 2p, p maximum 6 electrons. Till now, totally 10 electrons are completed, remaining 2 electrons are there. After 2p, next increasing order energy orbital is 3s. So 3s can accommodate 2 electrons. Why? Because only 2 electrons are left. Then the electronic configuration becomes 1s2, 2s2, 2p6, 3s2. This is the electronic configuration of magnesium. Now let us move on to aluminium. Aluminium representation is Al1327. That means it contains 13 electrons, 13 protons and as well as 14 neutrons. 27 minus 13. Now these 13 protons and 14 neutrons are there inside the nucleus. What about these 13 electrons? These 13 electrons first associated into 1s orbital 2, next orbital is 2s, next orbital is 2p. Totally 10 electrons are completed, remaining 3 electrons. After 2p, the next orbital is 3s, 2 electrons are accommodated. As per the Hund's rule and as well as above principle, next energy of orbital after 3s is 3p. So 3p can accommodate maximum of 6 electrons, but because only 1 electron is left, now the electronic configuration becomes 1s2, 2s2, 2p6, 3s2, 3p1 is the electronic configuration of aluminium. Next element is silicon. Its general representation is Si1428. That means it contains 14 electrons, 14 protons, 28 minus 14, that is 14 neutrons. These 14 protons and 14 neutrons are there inside the nucleus. Now what about these 14 electrons? These 14 electrons, first electrons are accommodated in 1s, after 1s 2s, after 2s 2p, after 2p 3s2. Till now totally 12 electrons are completed. Now the remaining 2 electrons enter into the 3p. P can accommodate maximum of 6 electrons, but only 2 electrons are left. The 2 electrons are accommodated here. The electronic configuration becomes 1s2, 2s2, 2p6, 3s2, 3p2 is the electronic configuration of silicon. The next element is phosphorus. General representation P1531. It contains 15 electrons, 15 protons and 16 neutrons. These 15 protons and 16 neutrons are there inside the nucleus. These 15 electrons, first 2 electrons are there in 1s, next electrons are there in 2s, next 6 electrons are there in 2p. After 2p the electron enter into the 3s. Then after 3s the electron enter into the 3p. Till now 14 electrons are completed. 12 electrons are completed and 3 electrons are left. The 3 electrons are there in 3p. Now the electronic configuration becomes 1s2, 2s2, 2p6, 3s2, 3p3. The next element is sulfur, whose general representation is S1632, which contains 16 electrons, 16 protons and as well as 16 neutrons. These 16 protons and 16 neutrons are there inside the nucleus. What about these 16 electrons? As per the Auger principle, the first 2 electrons enter into the 1s, next 2 electrons enter into the 2s, next 6 electrons enter into the 2p. Why? Because p has an ability of to accommodate 6 electrons. Next 2 electrons enter into the 3s. Till now 12 electrons are completed, remaining 4 electrons. The remaining 4 electrons enter into the 3p. Now the final electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p4 is the electronic configuration of sulfur. The next element is chlorine, whose representation is Cl1735.5. But while taking 17 electrons, 17 protons, while taking the number of neutrons, we are going to consider an average of 35 only, or sometimes depending upon the 36 we are going to take. Now it becomes 18 neutrons. Now these 17 protons and 18 neutrons are there inside the nucleus. What about these 17 electrons are enter into the 1s, 2s, 2p, 3s. Till now 12 electrons are completed, 5 electrons are left. So the total 5 electrons are accommodated in the 3p. Why? Because p has an ability to accommodate maximum of 6 electrons, but only 5 electrons are left. Now the electronic configuration of the chlorine becomes 1s2, 2s2, 2p6, 3s2, 3p5. The next element is argon, whose general representation is argon 1840. Now it contains 18 electrons, 18 protons. 40 minus 18, 22 neutrons are present. Now the electronic configuration of these 18 electrons are 1s2, 2s2, 2p6, 3s2. Till now 12 electrons are completed, remaining 6 electrons are completely accommodated in the p orbital. Now the electronic configuration becomes 1s2, 2s2, 2p6, 3s2, 3p6. These are all some of the electronic configuration of elements. Next element is potassium. Potassium general representation is K1939. As per this atomic number is 19. This means it contains 19 electrons, 19 protons. So these 19 electrons first, as per the rule, the first 2 electrons are accommodated in 1s, next 2 electrons are accommodated in 2s, next 2 electrons are there in 2p. Total number of electrons are 10. The next 2 electrons are there in 3s, The next 6 electrons are there in 3p. Till now, the total number of electrons are 18. With us, 1 electron is left. As per the Ohm's rule and as well as Aufbau principle, Euler chart, after 3p, the next energetic orbital is 4s, not 3d. Why? Because energy of 3p, 3 plus 2, that is 5. 3d, 3 plus 2, 7. So it becomes, the problem is there to avoid that the electron enter into the 4s. 4s can accommodate 1 electron. Now the electronic configuration of potassium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Now the next element is calcium. The general electronic representation is Ca2040. From this we can understand that atomic number is 20. Here calcium general representation is 20, Ca40. So it contains 20 electrons. These 20 electrons are first accommodated in 1s, next 2s, next 2p, after 2p 3s, after 3s 3p 6. After 3p the electron should not enter into the 3d, it enter into the 4s as per the Aufbau principle rules. Then that is 4s, 2 electrons are accommodated. Now comes to the next element, that is nothing but scandium, whose general representation is 21 Sc45. This means here 21 electrons are there and 21 protons are there. Why? Because that is the representation of atomic number. Now let us come to this 21, 1s2, 2s2, 2p6, 3s2, 3p6. After 3p the electron is not entered into the 3d. Yeah, first of all it is entered into the 4s. Till now 20 electrons are completed, remaining 1 electron. As per the Aufbau principle, after 4s the next energetic orbital is 3d. Then the next electron, that is the last electron of this element, enter into the 3d. The electronic configuration becomes 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. Now let us come to the titanium, where the general representation is Ti2248. Atomic number is 22. This means it contains 22 protons and 22 electrons. Now these 22 electrons, 1s2, 2s2, 2p6. Till now 10 electrons are completed. 3s2, 3p6. 18 electrons are over. Next the 2 electrons enter into the 4s. After 4s, next energetic orbital is 3d, and with us around 20 electrons are completed. Only 2 electrons are left. Those 2 electrons enter into the 3d. Now the electronic configuration becomes 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d2. Now next element is vanadium, whose atomic number is 23 and mass number is 51. Now that means it contains 23 protons and 23 electrons. These 23 electrons are accommodated like this: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Till now 20 electrons are completed. After 4s the electron enter into the 3d. 3d orbital can accommodate maximum of 10 electrons. Why? Because it has 5 orbitals. Each orbital can accommodate 2 electrons. But here because only 3 electrons are there, now the electronic configuration becomes 1s2, 3s2, 2p6, 3s2, 3p6, 4s2, 3d3. Now let us come to the chromium. Its atomic number is 24 and mass number is 52. Electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Till now 20 electrons are completed, remaining 4 are there, that is becomes 3d4. But this is not the correct representation in the case of chromium. Why? Because chromium is already a stabilized element. It is a stabilized element because of a little changes are there in the electronic configuration. The stability of the chromium depending upon the unpaired capabilities means the electrons are arranged in an ordered manner, that is nothing but incompletely adjusted manner, means by themselves they are rearranged, then automatically the stability of the chromium will be there. The rearrangement will be like this: 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5. This is the correct representation of chromium. Now the final electronic configuration of chromium is 1s2, 2s2, 2p6, 3s2, 3p6. 4s electron jump into 3d, now it becomes 4s1, 3d5. This is the special case in the case of chromium. Because of the half filled configuration, it gets stability. So for that, there is a rearrangement of electrons in the case of chromium. Now observe the next element, that is manganese, whose representation is Mn2555. This means its atomic number is 25. The electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6. After 3p, 4s, it becomes 4s2. Next orbital is 3d. Here, totally the electrons are 20, remaining are 5, so the 5 electrons are accommodated in the 3d. Though the electron of 4s is jump into 3d, there is no use. So for that, the electron should not jump into 3d. Next, in the case of iron, atomic number is 26, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Now comes to the cobalt, its electronic configuration becomes, now we are writing the electronic configuration of cobalt: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d7. Now observe the electronic configuration of nickel, whose atomic number is 28. So for that, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d8. Now if you see in the case of the copper, the electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9. This is not the correct method of representation. Why? Because the electron of 4s jump into 3d, then it becomes fulfilled configuration, then it gets stability. Now the electronic configuration becomes 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10. This is the special representation in the case of copper, like in the case of chromium. Now comes to the final representation, that is zinc. Atomic number is 30, mass number is 69, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and the last it becomes 3d10. These are all various electronic configurations of the elements, up to 30 elements. The atomic electronic configurations are placing a very important role in the deciding the nature of an element. In the next video, we are going to discuss what is the use of electronic configurations and what is the nature of the electronic configurations. Thank you.